Welcome to In 5 Minutes. Let us now discuss the very first receiver which is used for SSB-SC reception. It is called Beat Frequency Oscillator Receiver. BFO stands for Beat Frequency Oscillator. Let us go through the entire block diagram. Please remember that the basic concept used in the demodulation process will be to multiply the incoming SSB signal with the carrier signal, the locally generated carrier signal, and pass the output through a low pass filter. So let's discuss the block diagram now. So this is my receiver antenna. So the signal that is received through the antenna is nothing but SSB SC signal. Remember, now see, in this receiver all we should have is a product modulator block and the second block of a low pass filter. That's all we should have. But you can see there are multiple blocks here. So let's discuss how the reception is carried out. If you remember, the receiver that we use for the reception of double sideband full carrier was nothing but the super heterodyne receiver. No doubt there was another receiver available also, which is called tuned radio frequency receiver, TRF receiver, but there were a lot of drawbacks in the TRF receiver which we had overcome in the super heterodyne receiver. So the receiver that is used for the SSB-SC signal is also of the type super heterodyne. Now if you remember, in super heterodyne, we never carry out demodulation at the incoming high carrier frequency. We first down convert the incoming carrier frequency, or I can also use the term station frequency. We down convert the station frequency to a frequency called intermediate frequency IF. So my modulated signal is now present around intermediate frequency, and we give this signal to the detector or the demodulator circuit. So the very first setup that we have is to perform the down conversion of the frequencies. You can see that we first have RF amplifier and pre-selector. If you remember, pre-selector is nothing but a bandpass filter in the form of tank circuit. It will only allow the signal coming from the desired station to enter into the receiver. It will have a variable capacitance. If you vary the capacitance, then you are tuning the receiver to a new radio station, and it will now receive the signal coming from the new radio station, and so on. So right now, let's say the pre-selector is tuned to a specific radio station and we are receiving signal coming from that radio station, which is single sideband suppressed carrier signal. This signal will be present around frequency FC, which is the carrier frequency. It will be amplified by an amplifier, which is also the RF amplifier, because the signal has high frequency. It is now given to the RF mixer. There is RF local oscillator which will generate frequency FO, which will be of the form Fs plus IF. If you remember, the carrier frequency that we have, we also now call it Fs, the station frequency. So incoming signal is present around station frequency Fs. The local oscillator generate frequency Fs plus IF. At the output of the mixer, out of all the components present, we select the difference FO minus Fs, and if you take difference FO minus Fs, you get IF. So the entire range of frequencies on the input side which were present around Fs are now present around IF. If my incoming signal is upper sideband, it will be present from FC to FC plus FM. Now we are just using a different notation for FC. We are using a notation Fs, the station frequency. So this whole range of Fs to Fs plus FM is now converted to IF, which is the intermediate frequency, to IF plus FM. So we still have single sideband signal present, SSB SC press signal as it is, but it is now present around the new frequency of IF, which is low frequency compared to the incoming station frequency.